Hello everyone, welcome to In 5 Minutes. In this video, we are going to see the next problem on higher order differential equation with variable coefficients. So this is our question. So if you see here we have x square, x term. So this is a variable coefficient type of problem. So we know that this d stands for d by dx. D square will be d square upon dx square. I am going to substitute d square equal to this and d equal to this. So we get x square d square y by dx square. I am also taking y inside the bracket plus 3x, and instead of d we will get dy by dx plus 1 into y will be y equal to 1 minus x the whole raised to minus 2. If you observe this equation, we have x square as a coefficient of derivative. So this equation is of the form of Cauchy's equation. So in Cauchy's equation, we do substitution as z equal to log of x. Then our x is nothing but e raised to z. We also substitute x into d by dx equal to d. Then x square d square upon dx square will be d into d minus 1. Mind my words, this d is different from this d because this d stands for d by dx and here d stands for d by dz. Now we are going to substitute x square d square by dx square as this in this equation. So we get d into d minus 1 plus 3 into d plus 1, and I am taking y outside equal to 1 minus, instead of x I am going to substitute e raised to z the whole raised to minus 2. If I multiply this bracket, we get d square minus d plus 3d plus 1 into y equal to 1 minus e raised to z whole raised to minus 2. This minus d and plus 3d will become 2d. So our equation will be d square plus 2d plus 1 into y equal to 1 minus e raised to z the whole raised to minus 2. So this equation is of the form f of d into y equal to z. So this equation is nothing but higher order differential equation with constant coefficients. So the solution of this type of equation is given by y equal to yc plus yp. Now we will concentrate on yc. To find yc, we need an auxiliary equation. And auxiliary equation is given by f of d equal to 0. What is f of d? F of d is nothing but this term equal to 0, which is d square plus 2d plus 1 equal to 0. This part is nothing but d plus 1 the whole square equal to 0. So we can write it as d plus 1 into d plus 1 equal to 0. So the roots are d equal to minus 1 and d equal to minus 1. So these roots are real and these roots are repeating twice. So when the roots are repeated twice, then our yc is given by c1 plus c2. Since the roots are repeating twice, we multiply one constant with variable. We used to multiply by x in our all the previous problem, but here we are doing substitution as z equal to log x. So we multiply by z. So c2 into z e raised to minus of mz. M is minus 1, so minus of z. So this is our yc. Now we will find yp. Yp is given by 1 upon f of d into z. Here everything is in terms of z. So in our previous problem we used to have everything in terms of x. Now in this problem x will be replaced by z in the formula of yc and yp. Okay, so f of d into z, here we used to have x, now it will be z. So f of d is nothing but 1 upon d plus 1 the whole square into z is 1 minus e raised to z the whole raised to minus 2. So this term is not matching with any of the type 1, type 2, type 3, type 4, type 5. So it does not matches with any of the types, so it is of the type 6, which is 1 upon d plus m into v is equal to e raised to minus mx integration of e raised to mx into v dx, where v is some function of x. Then this is the formula of yp. Here v is function of z, so this formula will become e raised to minus mz. As I have told you, x will be replaced by z, so e raised to minus mz integration of e raised to z dz into v. So this will be our formula. So here we are going to split d plus 1 into two parts. So d plus 1 into 1 upon d plus 1 into 1 minus e raised to z the whole raised to minus 2.